Hi, everybody. Today we're learning about the fundamental theorem of algebra. So the fundamental theorem of algebra sounds super fancy. Basically, it just says two things. It says first, all polynomials have some kind of solution, right? They have some kind of solutions. And this is the big one. It says a function of degree n has n roots. So if it has a degree of x squared or 2, then it's going to have 2 roots or two solutions. If it's x to the third, it's going to have 3 solutions or 3 roots. If it's x to the fourth, it'll have 4. If it's x to the 10th, it'll have 10, right? So if whatever the degree is, that's how many roots it's going to have. Remember, our roots are on the x-axis, right? Our solutions and roots, the same words, zeros. All right, so this graph here, this red one that we see here, is this equation y equals x squared plus 2x minus 10. So the degree, the biggest exponent is x squared, right? So this says x squared. So it must have 2 solutions. Remember, solutions are the x-intercepts. It's where it touches the x-axis. So I have one right here and right here. So that's good. It says it must have 2 solutions. So on the graph, I see the solutions right here at -5 and right here at +3. Right, so this checks out. We have x squared, so it's supposed to have 2 solutions. So on the graph, I see them at -5 and at +3. When we write the equation, we're going to write it in what's called factored form. Right, factored form just means that we're going to put it in its parenthesis form. And you may remember from solving that when we have the solutions, we actually flip them for their factor, right? We change the sign. So if I have -5 or -5, I'm going to write x plus 5, right? Remember, you would flip that in order to get the solution. And then think, okay, if I have +3, what do I need to put here? I need to put x minus 3. This is the same equation as that right there. And both of these, right, would create this graph here. You can check it on Desmos if you want, but I promise it's the same. Actually, now that I'm looking at it, that should not be 10. Why is that 10? All right, check my notes. This should definitely be 15. That was a typo, my fault. Let me put a 15 there. Right. Okay, so we have y equals x squared plus 2x minus 15. That is the same as this equation here, which is what we see on the graph here. Right? Pretty cool. So we have x squared, 2 solutions. We see them here. We flip them for their factored form, and we find this guy here. So let's check it out with a cubic function, right? So you can see this function is our cubic, right? It's x to the third at its highest degree. So x to the third, x to the third. So how many solutions is it supposed to have? It should have 3 solutions. Right? I should be able to find them at the x-axis of my graph. I have one right here, -1, one right here at 2, and one right here at 3. Right, so I can see on my graph here that I have those 3 solutions. Then if I want to write my factored form of my equation, I need to have 3 parts. I'd have x plus 1, that's the flipped version of this, x minus 2, and x minus 3. Right, so it works for cubics as well. It's the fundamental theorem of algebra. So since it's x to the third as its degree, must have 3 solutions, which we can see on the graph. All right, let's check it out for a quartic. All right, so we have quartic here, right? I know that that is x to the fourth, right? Based on its shape, the M shape, technically negative x to the fourth, but that doesn't actually matter in this case. So since it is x to the fourth, it's going to have 4 solutions, or 4 roots, 4 things on the x-axis. So we see this one here, 1, 2, 3, and 4. So the first one, it looks like it's at -2. The next one's at -1. This one is at +1. And this is at +2, right? So I have my 4 solutions. So when I go to write my equation, I'm gonna flip those signs, x plus 2, x minus 2, I'm sorry, -1. Whoa, no, okay, sorry. We had x minus 2, this turns into plus. We have -1, this would be +1, got ahead of myself. This is +1, I'm gonna change it to minus, and this is +2, change that to minus, right? So we see that this equation here is what you get when you multiply all these things together. If you want to see it on Desmos, you can actually like graph it on Desmos like this. You just type it in exactly as you see it here, or as you just wrote it. So we'd have x plus 2, x plus 1, x minus 1, x minus 2. And you can see that one there. Remember that it's negative, right? Right, so since it is negative here, this one is positive. If I go all the way back to the front and put a negative in front, I can see that it is headed in the downward direction. So we can put a negative here. Notice the shape of this graph is what we see here. Pretty cool. All right, so you may be thinking, well, okay, miss, that seems pretty easy. If it's x squared, it has 2 solutions, x to the third has 3 solutions, x to the fourth has 4, right? But then you might be thinking, but I've seen some other graphs, right? There's something called multiplicity. This is when a graph is, or a solution is double counted or triple counted, right? It counts as 2. So this right here, where you see this comes down and bounces, this graph, or this point right here is considered a double root, right? It is a double root. When it goes straight through like that, this would be considered a single root, right? It goes straight through here. It doesn't stop or do anything else. When you have a double, you see it come down, just barely touch the x-axis and then bounce back up, right? This is not a root up here. Sometimes people think this might be a root, but it's not a root because it's not on the x-axis. So it has to be touching the x-axis. Right? So here you could say, okay, we have a single root at x equals -2. That's my single root. And we have a double root at x equals 2. Right? Right over here, we have a double root at x equals 2. This is good because I know that this is x to the third power, right? Look at the shape of it. It looks like a cubic, right? 1, 2, 3. So I know this is x to the third power, so it needs to have 3 solutions, right? 3 solutions. So when I write my equation, I need to account for the double. And this is how we do it. We write it exactly the same way. X plus 2, switch that sign, right? And x minus 2, switch that sign, right? To account for the double, we put an exponent right here, right? We put an exponent of 2 there, counts as double. And so it's coming down here, it's bouncing back up. So we see the double root in the graph looks like a bounce, and the double root in the equation is an exponent. Okay, so this graph right here, if we went ahead and graphed it on Desmos, we would see, okay, we have x plus 2, and we have x minus 2 squared. And we see that point right there, that is at double root. All right. And then finally, we have one more here. This one that looks the trickiest of all of them. This graph is an x to the 5th graph, right? It's an x to the 5th graph. So how many solutions should it have? It should have 5 solutions, right? It should have 5 roots. I only see 1 root right here and 1 root right here, right? That's kind of funky. So I see this one is coming up. It does not go through, it actually bounces. So So I know that's a double, right? That's a double. So I could say on the graph, I see a solution at 0. So x equals 0 is a double. Then it comes back down, and the next time that it hits the x-axis is at 2. So I know there's a solution at 2. Notice how it does something kind of funky. It like goes up, it flattens, and then flattens, and then goes up really fast, right? So it's increasing, sort of flattens out with its slope, and then it's increasing a lot again. This shape right here is called a triple root, right? It's called a triple root. Watch what happens to this point when I change the 2 into a 3. Do you see how it created that same shape, right? That double root shape right there. Or sorry, triple root shape right there, right? When it's a double root, it just bounces. But when it's a triple root, it makes this shape here, right? So a triple root looks like that. Even if the graph is negative and it's going down, it still makes that same shape. Still makes that same shape. So we have a double root right here, and we have a triple root right here. In the equation, we have the exact same thing, x plus 0, sorry, either plus or minus. We don't really have to put the 0, we can just put x. And then x minus 2. So we want to flip this sign, x minus 2. We want to account for the double with a 0. I'm going to put a 2 here, 2 squared, or x squared. And then the x equals 2 or x minus 2, this would be a triple. So we're going to put a 3 here. So we'd have x minus 2 to the third power. And this is our equation for this graph here. We can check it out by graphing x squared times x minus 2 to the power of 3. We can see that it creates that same line. Positive, headed up. Okay. So today you are going to have a Desmos. You're going to go ahead and click on the right Desmos for you. You have help videos for each of them available, and you are going to put a screenshot of slide 5 and a screenshot of slide 6, right? And then you'll be done. There is some extra credit. You have the game available. You have the test practice if you want, or there's some more practice here at the bottom. So there are lots of extra credit available today if you are interested. Thanks, y'all.